Okay, so to start off, here's the position versus time graph for the top, middle, and bottom parts of the slinky. Let's start with the velocity versus time graphs for each. So for the top of the slinky, it's a constant negative slope, which means our velocity graph is going to be in the negatives. And since it's pretty constant straight line, our velocity is just going to be a straight line in the negatives. Okay, now for the middle. The middle starts off with a flat slope. So it is going to be at 0 for the first little bit because this is pretty flat. So the velocity is at 0. And then as it starts to get more and more negative, we're going to see drop in the negatives a bit on the velocity versus time. And then it's going to start to smooth out more for the rest of the time because it goes kind of straight. And then right there is your negative acceleration, and it's pretty straight the rest of the time. So that's why it's 0 here. But also, it's flat here, but it's in the negatives. Okay, for the bottom, the bottom is pretty much a slope of 0 the entire time with a slight negative slope at the end. So here we're going to be 0 velocity pretty much the whole time. And then we are going to be at negative velocity. So there's a little bit of negative acceleration, and then it's going to be a straight line negative for the rest of the time. Okay, so those are what the graphs look like. The motion of each slinky. So the top slinky is just going to have a very constant negative velocity. So it's just going to be very constantly moving throughout the whole time. The middle slinky, in the center of mass of the slinky, it's going to not really move much at first, and then it's going to start to have negative acceleration and start moving, and then level off and keep moving at that speed for the rest of its travel. And the lower part of the slinky, the whole time that top part of the slinky is going to compress, the lower is not going to move, and then it's going to start to move. So that's why we see the velocity 0, and then right at the end it starts to move more. So that's how the forces act on the bottom part of the slinky. Is the top part. There's like tension or elasticity in the slinky. So the top part is going to come down and it's pulling up on the bottom. And then once we reach here, the top is no longer pulling down on the bottom. So now the slinky and the bottom part can fall. Now for the middle, we can see the middle is kind of just in the middle of the pack where it moves kind of slow. It doesn't move as much, but then as soon as that top part gets pulled down, it starts to fall fast again. And for the top, we know that the rest of the slinky, as well as gravity, is pulling down on that top part of the slinky, so it's gonna start to accelerate pretty fast in the beginning and then keep moving fast throughout all of its travel. And yeah.